Hello everyone. In the previous video, we discussed about various ways of detecting missing values in the data. Today, we will discuss about various ways in which we can handle missing values in the data. So first of all, we will load the data set. For that, we will import pandas. Then we will create a data frame by using a CSV file. We will pass the name of the file and we will indicate that the first column is going to be the index column. Then to view the first 5 rows of the data frame, we will make use of the head function. Now we can see that the CP column is having a missing value in the third row. But to get a broader view of missing values in the data frame, we will make use of the info function, as we learned in our previous video. So now we can see that some of the columns are having missing values in them. Now, there are two methodologies that can be adopted to deal with missing data. The first one is to drop or delete all those rows which are having missing values in them. And the second one is to fill the missing values with an appropriate substitute value. This is known as imputation. So we will first start with the first methodology and we will make use of the drop any function for that. So as the name suggests, the drop any function is used to remove missing values from the data frame, and it can be used in two ways. The first way is to remove all those rows which are having any kind of missing values in them. So for that, we apply the function like this to the data frame. We also make use of the info function along with this function to see the non-null count of the data frame after applying this function. So we can see that the non-null count for all the columns is same, which suggests that at this point in the data frame, that is after applying the drop any function, there is no missing value present in the data frame, because all those rows which were having any kind of missing values in them have been removed from it. Another way to use the drop any function is to remove all those columns which are having any kind of missing values in them. And to implement it in this way, we need to pass in x is equal to 1. Now x is equal to 1 corresponds to column and x is equal to 0 corresponds to rows. And by default, in drop any function, x is set to 0. That is why we didn't need to actually pass it in the function's argument for the case of the rows, but for the case of columns, we actually need to mention x is equal to 1. Now we also use the info function to get the non-null counts, and we see that all those columns have been removed which were having any kind of missing values. We can compare it with the information of the original data frame. Initially there were 14 columns and now there are only 9 left. So in both these approaches, we are losing a lot of valuable information, and that is not desirable. In the approach with columns, it should be noted that we should only drop those columns which are missing 70 to 80% of the data in them. Otherwise, we should resort to imputation. So this approach of dropping columns with having any kind of missing values is not always feasible and should be avoided. And in this particular case, where we are using drop any function for rows, we are actually losing out on valuable data because of this particular column in the original data frame, as this column is missing more than 80% of its value. At the expense of this particular column, we are actually losing out on the valuable information in this approach. Now, to rectify this problem, we will delete the CA column from the data frame. So we make use of the dropNA function to drop the CA column from the data frame. So we apply the drop function to the data frame and we pass in the name of the column that we want to delete, and we set the axis equal to 1, as axis equal to 1 corresponds to the column. Now, to see the result of this function on the data frame, we will run the cell and we will see that now there are 13 columns as opposed to the 14 columns in the original data frame. This is because the CA column is now removed from the data frame. Now, to actually reflect this change in the original data frame, we will be assigning this result as the original data frame. Now, if we make use of the info function, we can see that there are 13 columns and some of the columns are still having missing values, but they are not so significant in number. So now we can make use of the dropNA function with the approach where we delete the rows which are having missing values. So in this way, we see that we were able to save a lot of information this time. So that is how we make use of the dropNA function for the first methodology. And we also learned how to use the drop function to delete a column from the data frame. Coming to the second methodology, there are quite a few functions that we can make use of. First of them is fillNA. Now, like dropNA, we can use fillNA also in multiple ways. So, the first approach is to fill the missing values with the preceding values in the respective columns. Okay, so basically, we will be filling the missing values with their previous values. For that, we just apply fillNA function and we pass in the method as pad. If we now check out the data frame, we see that initially this was a missing value in the data frame. We can see it here as well. So the CP column was having a missing value in its third row, and now this missing value has been replaced with the preceding value of the column, that is 2. And in the similar way, all the missing values have been imputed in the data frame. To check this out, we can make use of the info function instead of the head function. And we see that we were able to retain the original non-null count of the data frame. So that is why imputation is preferred over dropping in case where we are not losing out, in case where we don't have a lot of missing values. Now, another way to use fillNA function is to replace the missing values with the next value in their respective column. So, for this particular use of this function, we pass in the method as bfill. Now, we see that the missing value has been replaced by the next value in the data frame, that is 1. Another way to use fillNA function is to use any arbitrary value to replace the missing value. So let's say we want to replace the missing value with a particular number, let's say 100. So we will just pass in 100 to the fillNA function, and it will replace all the missing values in the data frame with the value of 100. Okay, and we can check the same using the info function that all the missing values were dealt with in the data frame, and as we can see here, all of them were replaced by 100. So in this way we can choose any value, be it 0, be it 20, or any number actually. Also, instead of passing any arbitrary number to the fill any function, we can also pass any string as well. To see it, let's just reload the data, and now the data is having missing values actually. So now let's say we want to replace the missing values with the string called ABC. So the missing value will be replaced by ABC, or any arbitrary string value or any particular number that you want, any value actually. You can also replace the missing values with the mean or median or mode of a particular column as well. Instead of applying this particular function on the entire data frame, we can also apply it on a particular column. For that, again, just load the data frame again. And now let's just fill the missing values in only the CP column. Okay, so we will access the CP column of the data frame, and to that we will apply the fill any function, and we will replace the missing value with the XYZ value. Okay, so now the third row in the CP column is replaced by XYZ. So you can either apply the fill any function to the entire data frame or to any particular column as well. So in this way, if you are applying it on a particular column, you can instead of using any arbitrary value, you can use the median or mode of the column as well to replace the missing value. So if the column is having continuous numerical values, then it is advised to impute the values with mean or median values. And if the column is having categorical values, then a mode should be used. Now, another function that can be used in a similar way is the replace function. Now, replace function is used to replace any value in the data frame with any value of your choice. Let's just see an example. So let's just call the data frame again. Yeah. So now to replace this missing value, we first import numpy as well. Okay, numpy is np. And now we apply the replace function to the data frame, and we replace the nan values with a particular number, say 200. Okay. So now the missing value has been replaced with 200. But using this replace function, not just the missing value, but we can replace any value in the data frame. Let's say, for example, we want to replace 130 with the string called XYZ. Okay. So we want to replace 130 with XYZ. So you can see that now all the cells that had 130 as a value in them were replaced by XYZ in the data frame. So that is how the replace function works. It is very similar to fill NA. The basic difference between fill NA and replace function is that fill NA is particularly and specifically made to replace the missing values with any value, the arbitrary value or the previous value or the next value in the data frame. But replace function can be used to replace any particular value of your choice with any particular value that you want to replace it with. So this is the basic difference between the fill any function and the replace function. And just like the fill any function, you can use the replace function on the entire data frame, or you can use it on a particular column as well. Another way to impute the missing values in the data frame is to use the interpolate function. The interpolate function works on the principle of interpolation, which is a statistical method by which related known values are used to estimate an unknown value. And it is similar to the approach of linear regression only. So what happens is, in this particular column, let's say the CP column, all those values which are not null are used to estimate the value of the missing values. So to apply interpolate function to the data frame, we pass in the method as linear because we want to perform linear interpolation. But there you can choose from other kind of methods as well. For example, time, nearest, pad, etc. To know more about different kinds of methods of interpolate function, you can look at the documentation of this function. So now we see that the missing value has been replaced by implementing interpolation on respective columns of the data frame, and we see that all the missing values have been removed from the data frame. So these are some of the ways in which missing values can be handled in the data frame. Let's just recapitulate. So there are two methodologies. One is to drop the rows and columns which are having missing values, and only those columns should be dropped that are missing 70 to 80% of the data. And before removing rows with missing values, we should ensure that no particular column is missing up to 70 to 80% of the data. Otherwise, we will be losing on valuable information. In case of imputation, we can perform imputation using the fill any function by either replacing the missing value with the previous values or with the next value in the respective columns of the data frame. And we can also use fill any function with any arbitrary value. But it is not advised to replace the missing value with any arbitrary value of your own choice, because that significantly reduces the accuracy of the models. And instead of any arbitrary value, it is preferred that for numerical columns, mean and median should be used, and for categorical columns, the mode of the column should be used. The same can be done using the replace function as well. And the basic difference between the fill any and replace function is that fill any function is specifically made to remove the missing values from the data, and replace function can be used to replace any value in the data frame or any particular column of the data. And the interpolate function is a statistical method to estimate an unknown value based on the values which are known in a particular column of the data, and that those values are used to estimate the missing values from the data frame. And that is how we can deal with missing values in the data frame. Thank you, and we will keep posting more such informational videos.